For Module 5, Lesson 15 exit ticket, we are going to use our area model to help represent when we create fractions that have equivalent values but have a common denominator. So the two fractions I'm comparing in number 1 are 3/4 and 4/5. So I'll write 3/4 up here and 4/5 down here. And I'm just going to create my area model for 3/4 and my area model approximately the same size for 4/5. And I'm going to go ahead and I'm going to shade in 3/4. 1, 2, 3 out of the 4, and 1, 2, 3, 4 out of the 5. And now I'm going to consider, what do I need to do to find comparison fractions? Well, when I look at the denominator of 4 and 5, I know that the shared first factor would be 20. How do I get from 4 to 20? I multiply by 5. So I multiply the denominator by 5, I have to multiply the numerator by the same amount. That way both numerator and denominator increase the same rate. So 3 times 5 is 15. Down below, I know that 5 has to go to 20, and I do that by multiplying by 4. Whatever I do down here, I multiply up here. 4 times 4 is 16, and automatically, I probably don't need this area model, but it's helpful to visualize this information. So what I'm going to do is I'm going to recognize that I need to make this from 1, 2, 3, 4 pieces into 20 by creating 5 sections, 5 rows. And now when I count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 16, 17, 18, 19, 20. I have 15 shown out of 20. Down below, I know that I need to take this 4/5 and break it into 20 even pieces by creating 4 additional groups. So when I look at this, I now have 4 rows by 5 columns. And when I count up the shaded amount, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, as I see here. And I know that 16/20 is greater than 15/20, so I know the equivalent fraction of 4/5 is greater than the equivalent fraction of 3/4. We're going to try this again down below. And I have some space, so I'm going to take advantage of that. I have 2/6 and 3/5. And I'm going to create, hopefully, area models about the same size. They're meant to be, but my handwriting can be messy sometimes. I know that. So I'm going to break this into groups of 6. And this one into groups of 5. I'm going to shade in 2 pieces. And I'm going to shade in 3 pieces. And even just looking at this, I have a guess of which one's going to be larger. But I know I need to go through the process to solve it to really know the answer. So what could be shared between 5 and 6, these denominators that make them common? Well, if I multiply them by each other, I will get a denominator of 30. Well, how do I get from 6 to 30? I multiply by 5. Well, if I multiplied 6 by 5, I have to multiply the numerator 2 by 5. And 2 times 5 is 10. Down below, to get from 5 to 30, I had to multiply by 6. And in this case, I'm going to have to multiply the numerator by the same thing as that denominator. So 3 times 6 is 18. Again, as I mentioned, another sign visually that we can kind of take a guess at this, but we're going to complete this tape drawing. So in order to get this area model to represent 30, I'm going to actually have to create 5 rows. And we're going to double check to make sure this is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 15, 20, 25, 30. So this currently represents 10/30ths. Down below, how do I make this represent 18/30ths? Well, I'm going to have to break it into 6 groups. 1, 2, 3, 4, 5, and 6. And when I count up these pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, plus 6 would be 24, plus 6 would be 30. So this now represents 18/30ths. And when I look at these equivalent denominators, equal denominators, and I look at the numerators, I can tell that one is larger than the other. 18/30ths is greater than 10/30ths, which means the fraction that has the same value as 18/30ths, 3/5, is greater than the fraction that has the same value of 10/30ths, or 2/6. So 2/6 is less than 3/5.